I'm kind of an imposter here, actually. I'm not actually a web developer for my day job. I work on a desktop app. But I'm very excited generally about the way the web is evolving from sort of a document platform to an app platform, and something that you can build something that's as good as or a better experience than something we've been used to in delivering with native apps. And I'm really excited about the way that React can help us to do that. But I'm also interested in looking at trying not to make some of the same mistakes that I've been used to from the native world. And something that's always been a pain point is when we write our app and we're writing tests for it, doing the business logic, straightforward. And then there's always usually a sticking point somewhere when it comes to the user interface. And there's for a number of reasons, but I wanted to, compared to the way I'm used to stacks being set up for, I guess, in other web frameworks and in desktop apps, React gives us a somewhat different way to think about the user interface, and it also comes with a sort of a set of idioms and patterns and ways of thinking. And I wanted to understand how React's concepts around components, data flow, and the virtual UI tree could help to make building user interface tests a bit less painful and deal with some of the problems that we've had with them. So this is going to be an overview of sort of what I've learned and some of the resources that I found useful. So today I'm talking user interface tests happen at a lot of levels. You have your UI tests for individual components at various levels of the stack. Your sort of integration tests, which say test most of the system, but maybe not your backend services, and then your full end-to-end tests. So I'm focusing mostly on unit tests today, but what I'm trying to do, what I was looking for is tools and techniques that wouldn't mean that I didn't need a completely different system for, say, unit testing than integration testing and so on. Something that kind of adapted as I wanted to scale up and cover more of the system. But firstly, I wanted to ask, well, why is it that testing the user interface is any more difficult than testing the rest of our system? The first problem is that usually there's some heavy machinery involved. So in the case of we're testing a web app, then usually we'd have to fire up a browser, and there's something that communicates with that. And when there's or if we're testing a mobile app, then we might actually have to have the device somewhere. Or if we're testing a cross-platform app, then we make sure it runs on each system. And there's sort of a windowing system and all kinds of other stuff involved. And the problem is that makes for a somewhat flaky environment. For the rest of your business logic tests, you can simply run something at the command line in a nice constrained way, and it's not subject to the whims of whatever the browser feels like doing that day. And then next, when something fails, it's useful to be able to debug it quickly. And this is where all that machinery and these extra layers kind of complicate things. And unfortunately, this can make things somewhat fragile. And in particular, if we have lots of moving parts, there can be timing problems as well. So something that kind of makes React attractive is it has been described as kind of a virtual machine for user interfaces. So that sort of isolates, it gives us kind of isolation, and we're used for it in other stacks, the way that, for example, Java or JavaScript isolates us from whatever processor architecture the user has. And it's interesting to think whether that can help us when it comes to writing tests as well, to help us focus on the thing that we actually want to test and not the rest of the environment. So thinking about user interface testing with React, firstly, I'm going to go briefly over the basic setup for testing a React app and how to get a test that works both on the command line and in the browser. Running in the command line is useful because, of course, it's fast, it's near your development tools, it's convenient, but there's ultimately no substitute for getting it running in the real browser because the browsers are enormous, complicated beasts, basically an operating system unto themselves. So it's useful, and also they have a fantastic set of development tools for debugging these interfaces. So it's useful to be able to have sets of tests that you can take between the two. Then I wanted to think about the sort of the principles and the idioms of React and how that we could apply them when we're writing tests and how they could perhaps make us write tests that are easier to debug, that fail faster when they're going wrong, and that generally help us have a more productive workflow. And I wanted to look at also some of the new features in the recent 0.13 release of React, which can help us in this. And a little bit about how we can hack Node's module loading system for fun and profit in order to help us isolate the different parts of the system we're testing. And lastly, just a couple of sort of design patterns that are emerging that can help us with this. So as an example, or just for reference, I'm just going to use a poor man's Twitter client as a sort of an app for expedience. So this is very simple. It's a feed. It shows a list of tweets. I can refresh it, and it will fetch new data from the server. But I think that shows enough for what we need. So the basic out-of-the-box tool that React gives us for writing a test, and where we start, is a library called the test utils, which ships with React. And what this does is lets us take a component and render it into a DOM element. And then when we've rendered it into a DOM element, we can access it, check various properties of it, and we can also simulate events on it. So we can make sure that the component looks the way it's supposed to and that it reacts the way we expect it to. So a typical test might look something like this. We set up some fake data, say for our tweet. We call render into document, and this takes the component and renders it into a DOM node. And then we can get hold of, let's say, a piece of the component that comes back, and then check that did it display the right text. We could then also, say, simulate an interaction on it. Now, in order to actually run this test, usually, we need some kind of, a browser environment. We'd have to fire that up and get that working, and that would make our continuous integration system somewhat more complicated. Fortunately, we can use a fake DOM environment for most of the testing that we want to do, because we don't really need all the, all the real paraphernalia that the browser comes with. All we're ultimately interested in is if we can generate the right DOM structure, then we can trust that the browser will render it properly. So JS DOM is an incomplete DOM environment, but it's good enough for most of the testing that we want to do. And in order to use it, what we would need to do is something to know about React is that when it starts up, when you require it for the first time, when you load it, it inspects its execution environment and checks that do I have a window, do I have a document that I can put things into, do I need that funny IE hack for scroll events, etc. And all the other quirks that a browser might have. So that happens as soon as you load the React code. So what we need to do in our test is, first of all, set up JS DOM. And that needs to happen before actually anything runs. And then once we've done that, we can require React and then use whatever testing framework we like, Mocha, Jasmine, etc. So if you are using sort of Facebook's tutorials, they recommend their own fresh framework, which is called Jester, which will set this up for you. Jester does have some disadvantages, though, which I'll come on to later. So if you wanted to if you want to create your own structure, it's easy enough to get it going with whatever testing framework you like. And when we come to run tests in the browser, all that we have to do is just take this piece out, and we'll use the real DOM environment. And then we can take our code, run it through Browserify, Webpack, etc. And then we get a test bundle that then works in the desktop. That works on the command line, and something that then works in the browser as well. But so far, we're not really taking advantage of React in any way. This is something we could do with other frameworks as well. The first problem that we run into is, testing simple components is fine, but our application is a big tree of components. And as we move up the tree, if we're relying on checking the DOM, then when we change something at the bottom of the tree, if, for example, we're rendering our tweet list, and we're relying on each individual tweet having some class, if we're checking for that, then the problem is, if I, say, change my CSS, then I promptly break not only the test for my tweet item, but I break the test for the whole list. So the question is, what we want to do is sort of test each individual component in isolation. and make use of the tools that React gives us to do that. So thinking in a React way means thinking in terms of not sort of DOM elements and a structure of DOM elements, but thinking in terms of components and thinking about how data flows between them. And preferably, a good idiomatic sort of React component will be pure in the sense of it takes a stream of input and we get a stream of outputs. And ideally, we want to sort of be able to forget around everything around it. And if we zoom in on an individual React component, we have effectively it's often talked about as a function of props in, DOM out, but it's a bit more than that. We've actually got a stream of properties going in and event callbacks from when I click on things. It might be fetching data from Flux stores going in, etc. And then what we have coming out is a stream of component trees that change as the data coming in changes. And we have a stream of callbacks or actions, etc. And thinking about it this way allows us to, first of all, isolate what it is that we're testing. But there are some other cool things we can do as well. So the input in a unit test, the props and the callbacks that comes in are usually predictable, and we write them by hand. But there was a great talk at a recent Portland meetup for React where someone describes simulation testing, which is effectively where you put random inputs in and that you just check that the outputs coming out have certain properties about them hold. So we want to cut out the rest. When we're testing our React application, we want to be able to cut out the rest of the components around what it is we're looking at. And React gives us some tools for this. So the first one is, rather than checking what DOM elements come out, whether they're divs, spans, images, etc., when we're testing components higher up the tree, we actually just want to say, this tweet list, is it rendering the right number of tweet items, etc.? And React has a set of methods that will let us traverse the component tree that a component produces and make queries on the types of elements that come out. So here, for example, I'm rendering a list of tweets, and I'm counting the number of tweet item children that it has. So that way, if, for example, I change my CSS, etc., then I don't need to worry about this particular test breaking. Only the one that actually tests the component where I made the change will break. The next thing that can be used, so this helps us with making the test a little bit less brittle. But the problem is, I'm still rendering everything down. So if, for example, say something in when I render my tweet item component, if that throws an exception, it's still going to cause everything higher up the tree to fail. And this is where there's a new feature in React 0.13 which can help with this. And it's called shallow rendering. And what it does is we're used to React being able to, first of all, render to an entire tree of components to a string, and also being able to render a tree of components into the actual DOM. And there's also been a number of other implementations, so rendering to canvas, rendering to native, and so on. And this is sort of a third, in a way, the simplest possible option. It's renders to null. So what happens is when React gets the render tree back, it will instantiate an appropriate type of a wrapper component as such for each of those things. So if, for example, the wrapper component is responsible for calling your callbacks, so saying, yes, this component is mounted, please render your children, your props have updated, all that stuff. So what shallow rendering does is you ask it to render a component, but for each of the children, it will render them, but it will just create a fake instance, and that fake instance won't call any callbacks, so that your children will never get mounted. They will never get their render function calls, and effectively you're cutting the tree off at that point. So if, for example, that orange thing is my tweet list, it's gone and rendered each of the tweet children, and I can test the type of component that comes back, and I can say, yes, my Twitter list, my Twitter feed is rendered, and it's rendered the right items, and it's rendered them in the right order. But it won't keep going down the tree, so I don't need to worry about it. Won't, for example, supposing in the tweet item code there's a bug, that then won't cause this test to fail. So the way you'd make use of that is it's in test utils. There's a new function called create renderer, and this gives you back a new rendering engine, if you like, called shallow renderer. And what you do is you render your component, and then you say, give me the shallow output of it. Give me the, so in our UI virtual machine, this is almost like a new architecture that you can render to. And when you get the output back, you can check the props and the state that were passed down to the children. So if we think of our components as kind of a pipeline starting from the top of the tree and gradually going down, we can inspect what came into our list component, what came out of our component, but we sort of isolated it from everything else. In theory, doing this would allow us to test a lot of the UI, all the higher level components, without ever having a DOM at all. In practice, this is a new feature. It has some limitations. So, for example, at the moment, the child objects don't have refs, which means that you can't use that to get hold of a particular child object. You can check the number of them, you can iterate over them, but you can't get refs to them, and you can't actually dispatch events to them. What you can do is, if you passed a callback down to a child, then you can invoke that. So, shallow rendering helps isolate the rendering part of a component, but there's more to a component than just rendering it. We still have all the other logic that the component might involve, for example, fetching data, or when I click on a button, dispatching an action to some store. So the question is, how can we self-isolate that aspect of it? If you're used to Angular, then you would use dependency injection for this. And in other frameworks as well, that you might do dependency injection manually. But what about React? So first of all, Facebook's testing tool is called Jester, and it's the one that if you go to, on the React website, they'll recommend you use. And the nice thing about React Jester is it's a batteries included library. It provides everything it provides with essentially no configuration, everything you need to run a test on the command line. It sets up a JS DOM environment for you. It will handle automatically parallelizing your tests. It's actually quite slow just starting a Jest test instance up, but the idea is to have good throughput when you have an awful lot of tests. And it also gives you utilities for fast forwarding time, which is useful when you're testing things like animations in your user interface. But the most interesting feature of Jest is its automatic mocking. And what Jest observes is that if in a modern JavaScript application that's written using common JS style and bundled up, all of your dependencies that your component has will enter the system via the same way, via require. And what it does is that every time you have a module that implements a particular component, every time you have a require statement, what Jest will do is fetch the original module, inspect the structure of what comes back to have a look at the properties it has, the methods, etc., and then it will generate mocks for them. The mock objects, you can call the same methods on them. They will record data about how often they called, etc. And then they will just, if you try and make use of the return value, they'll just return undefined. So this was great. I thought, my project. I've written tests for the business logic. I've been afraid of writing the UI tests because I know how complicated it's been in the past. But I really should do that now because the user interface is starting to be the bulk of my project. Let's use Jest. It's the recommended testing tool, and immediately you run into some caveats with it. So automatic mocking is its most interesting feature. But if your code isn't ready for it, it can be an interesting experience. And the reason for that is that whenever you get a return value from something that Jest has mocked, it returns undefined. And JavaScript, being JavaScript, that undefined can work its way through a long line of chains of your system before it eventually turns into something that becomes an error. So, for example, you'll have some mock function some way, you were relying on something having a certain type or property, and then by the time you eventually get the error message and your test suite has crashed with an awful long stack trace, it takes a little while to work your way back to figure out what it was that got mocked when you didn't want it being mocked. The other thing is it currently doesn't run in the browser. If you're following the previous steps, you can test a lot of your React application on the command line, but still the DOM is a big, complicated thing, and I hate to say it, but browsers are not perfectly compatible. And JS DOM, is a decent implementation of the DOM, but it doesn't have every latest feature here and so on. So it's useful to be able to actually run the same set of tests in the browser and on the command line. And the other thing is also all the conveniences and affordances of browser developer tools. That it's useful being able to use those. So when your test isn't working, it's useful to be able to fire it up, run half of your test in the browser, and then inspect the DOM structure, etc. On the upside, however, Jest mocking, automatic mocking is completely thorough. So you won't ever end up writing a test which inadvertently relies on some other module which you didn't think it was. So, for example, you won't have a test that makes an HTTP request when you weren't expecting it to, and then wonder why your test breaks in an environment with no network connection. But the basic kind of concept of hooking into Rewire makes a lot of sense, because the nice thing is, because React components effectively are just JavaScript, our stores, our components, everything in our application is structured the same way. So it provides, if we can figure out how to inject things via Rewire, then we can do that for the whole of our app. We don't need a different approach to mocking out things that our components might depend on, mocking our data sources. If we want to have, let's say, a fake network service, we can mock that the same way. So how generally can we hook into Node's Rewire system? Well, it turns out that Node's module, the code logic which implements the module system in Node is itself a module. It's not actually that complicated. It's only a few hundred lines of JavaScript, and you can require the module that implements Rewire and have a slight inception moment. And so if you do this, what you'll get back is a module that will give you effectively, it's not documented, so caveat emptor, but given how simple it is, and there are a number of libraries built on top of it that may deal with any changes underneath for you, you can hook into things like here, for example, you can inspect the module cache. If you want to override what Rewire does subsequently, you can do that. So there are a number of libraries that deal with intercepting Rewire and overriding them to do what you want. The one I looked at was, or one of the looked at several, and the one I'm going to talk about now is called Rewire. And what it does is, instead of requiring a module, you rewire it instead, and that will fetch the original module and give it back to you. But what it will do is it will add on some accessors. So it lets you reach into the internals of the module and access private variables. And every other module that module's required will be a private. So for example, my tweet list component requires the tweet item component. And what I can do here is I can rewire tweet list, and then I can replace the tweet item, the reference to the tweet item component, with some stub, which can do whatever you want it to. And the nice thing about this approach is that it works not only on the command line in Node, but there's also a Webpack module that works as well. And actually, if you look at the module loading code in Node, the output that it generates is, if you've ever looked at the contents of a Browserify Webpack bundle, essentially the code that Node generates and feeds into V8 is very similar. It takes the module, wraps it in a function, and then that feeds that to V8. So compared to Jest, for mocking things out, this requires us to do more work, and we'd have to do this for each dependency that we want to mock out. But on the other hand, it gives us more flexibility. So it means that whereas Jest would go and mock everything for you, we may wish to have different levels of tests. So for example, an integration test which tests, say, most of our application but uses a fake data source. In this case, for that, we could use Rewire, but only mock out selected parts of the application. And even if you want to mock in different ways in different tests, you can do that. So that covers isolating individual components in our tree. But what about when it comes to more complicated ones? Components that fetch data, components that dispatch actions to Flux stores, etc. And there's This is a case of old ideas revisited. There's a concept that's that was first brought up in a talk in January at ReactConf about how to write high-performance React components. It's also starting to become a pattern since React version 0.13 dropped support for using mix-ins, which were how in the early implementations of Flux you used to load data into your components. And Relay itself works this way, which is that you separate out your components into those which are purely visual and those which are effectively containers or wrappers around them. And the idea being, first of all, that it makes your visual component, that's my widget in the middle there, is reusable. So I can use that in different contexts. So for example, in the demo app I mentioned earlier, the refresh button would be a widget. And then it would have some container that implemented the specific logic to it, the specific logic for it. The widget can be a pure function that just takes the data as input, doesn't dispatch any actions, isn't responsible for querying any external data sources. And then the container, which is responsible for the context-specific logic. And we can test each of those separately. So for the widget container, we're only interested in making sure that it fetches the right data, that it renders the children correctly, and when the child is interacted with, that it dispatches the correct actions. So if we're following the Flux pattern, we wouldn't actually check that the model is mutated in the correct way. All we need to make sure is that when I, for example, click on a widget, it will dispatch the correct action. So this pattern is something that I think is looking the case that the React applications will increasingly be written this way. And in terms of looking at the existing sort of Flux implementations out there, there are a number of them that are now starting to, they will provide the container controller that does the data fetching for you, so you don't need to write that yourself. And in the case of Relay, the widget container here becomes a Relay story component, which deals with querying the widget, working out what data it needs, going off and fetching it, and then only when it has all the data will it actually then go and render the child. So this architecture, if we're coming from a background working with other web frameworks or native apps, starts to look pretty familiar if we just change the labels slightly. That's not a bad thing. It's old well-tested ideas revisited. The one thing that is a little bit different here is that usually in almost every framework I've had experience with before, the view and the model have pretty clear roles, and then the controller has always been somewhat more nebulous. Exactly what its responsibilities are, what data flows into it and out of it. What we have here, at least, is a slightly more sort of prescriptive pattern, and we can apply the general idioms of React to help us think about how the data gets into it, what its responsibilities are and are not. So I hope this has been useful. In terms of getting started with running running tests in the browser and also in Node, there's a basic starter project there, and there's a number of links that I'll put up to other projects that are around that provide a starting sort of environment. There's also a number of existing talks on getting started with testing React applications. And I'd particularly recommend the one on property testing, which is a useful way to cover the many ways your application can fail that you didn't think of when you wrote it. Thank you very much. Any questions?
Well, hello. Great talk. Thanks for sharing all your experiences with testing in React and for helping everyone get forward with that. I read a post recently where the blog author said something like, when testing React components, especially if you are using pure render mixin, you don't have to worry about ever testing props, and in extension to that, you don't have to worry about testing most of your dumb components that don't manipulate, they don't keep an internal state, that don't handle any of the logic that is handled more upstream. Would you agree with that? Or do you think you have to test every single component that you write?
Well, clearly there are going to be more bugs in the more complicated parts of your application. But the nice thing, the nice thing about it depends also on what the cost of something failing is. So if you've only got a certain amount of effort that you're prepared to allocate to testing, then you would need to find the piece of your application that's most likely to fail and spend the resource on that. I would say that, just the same way we would test some other pure function, we would want to be able to, that we're in another environment, whether it's business logic, etc., then for the user interface, that can still have value. It depends, again, what the cost of it going wrong is.